The Sky This Month with your host, Dave McDonald.
Hello and welcome to The Sky This Month 2020. I'm your host, Dave McDonald. This is a great month. It's Mars month, and I'm going to explain that to you in a little bit. First, I want to let you know I'm doing a special program October 2nd in the evening at 7 o'clock for the McAuliffe Shepherd Discovery Center at starhop.com, starhop.com. You need to register for the event, but it is free. In a moment, I'm going to be introducing to you Todd J. Barber, who's the lead propulsion engineer for the current NASA mission to Mars. And I'm going to show you a short video clip right now about the Perseverance spacecraft. And then at the end of the show, I'm going to tell you exactly where to find Mars in the night sky for October. Don't miss it. Enjoy. Well, this is October 2020, and October features the opposition of Mars. Mars is at its closest approach in a lot of years, and the week before October 13th is when we're actually closest, but the time of opposition is when the sun sets, Mars rises, and is visible all night. So I thought along the lines of the Mars theme, I would have a special speaker come to chat with us about the current mission, the Perseverance mission, which is now on its way to Mars. And I want to introduce to you the lead propulsion engineer for Perseverance mission operations, Todd Barber. So welcome to the show, Todd.
Thank you very much, David. I'm delighted to be here today.
Yeah, and thank you so much for taking time out of your busy schedule to be with us, because the universe is a busy place.
It feels especially so on this mission. We had a 2-week launch delay, which is not unusual, but we already had a quite short cruise to Mars. So basically from launch through landing is a short 6.5 months, and we're used to maybe 8 or 9 months. We have the same set of activities. We have to squeeze in that smaller amount of time.
Yeah, and is part of the reason it's a shorter trip, is the rocket faster, or is Mars and Earth closer, or both?
It's really the kind of trajectory we chose, and then also a bit from the position of the planets too. And I'm an old amateur astronomer from decades back, so I always have to take some time when I'm in the middle of all these Mars missions, and this is my third set of Mars missions, because I always know opposition is going to happen somewhere during our cruise from Earth to Mars, just the way the planets line up.
And well, let me ask you, Todd, how is it that you got involved with NASA in the first place?
Yes, so this is October of 2020, and the 22nd of October marks my 30th anniversary at NASA JPL. This is my first job right out of college. Got a bachelor's and a master's in aerospace engineering from MIT, and then straight to JPL, living out that childhood fantasy and dream of exploring the planets. And then my first Mars mission, I got through about 15 years of 13 years or so of a JPL career without touching Mars at all. But the the allure of Ares was too strong back in about 2003, and I joined the Spirit and Opportunity mission as a propulsion engineer, again for flight operations. So I end up flying these missions rather than design or build them. That went well. I didn't crash either Spirit or Opportunity, so they asked me back for Mars Science Laboratory Curiosity in 2011, 2012. And I had the great pleasure of working that mission as well. And here we are another 8 years later, another Mars mission. So, but this time I'm the head propulsion person in flight, so a new set of stressors, but incredibly excited for Perseverance and its upcoming landing on Mars.
Well, that's neat. So just you mentioned Curiosity, so you were involved with, as you said, Spirit and Opportunity, and Curiosity, which, if I remember right, landed August 5th, 2012.
That's right.
What's the quick update on Curiosity? How's it going?
Curiosity is doing amazingly well. It was a design for a 2 Earth year, 1 Mars year mission on the Red Planet. We are 8 years and counting into its 2-year mission. We are driving up the hills and canyons of Mount Sharp, exploring clay units and sulfate units, and still doing groundbreaking science on a rover that's 4 times its design life and still going well.
And Spirit and Opportunity also well exceeded their design life.
By even a larger factor. So those were only to last 90 sols or Martian days, which is about 92 Earth days. We'll call it 3 months. Spirit made it 6 years into its 3-month mission until it finally got stuck in the sand and it got too cold to operate over a Martian winter. Opportunity went 14 and a half years into its 3-month mission. And we just said goodbye in the last year or two when we had the mother of all Martian dust storms, which basically worse than the air quality in California during all the wildfires. We didn't get enough solar power to keep the rover operating. But though a few tears were shed, it's hard to get too sad when these rovers lasted many, many years into a 3-month mission.
Yeah, it's amazing. We certainly are getting our money's worth, so to speak, out of these NASA missions. And now Perseverance is on its way to Mars. How did you get connected to Mars and have the opportunity to do so many missions related to Mars?
Yeah, I think it was just the audacity of Spirit and Opportunity. That mission was about 38 months from cocktail napkin to launch, which is incredibly short by our standards. So they needed to kind of throw all hands on deck and needed some extra help. I was already had set myself up to be an operations career person at JPL in propulsion. So a mentor of mine at the lab needed some help, and he had worked even on Mars Pathfinder. So that allowed the door open a bit to come into the Mars world. And then once you're in there, it's very addictive and a lot of fun. So I sought it out for Curiosity and Perseverance as well.
Well, that's great. And what is it that you like? I imagine obviously it has to do with propulsion, as you are the lead propulsion engineer for Perseverance mission operations. What exactly does that mean? What do you exactly do?
Yeah, great question. My primary focus is on what's called the cruise stage, which is the part of the vehicle that actually ferries the sexier, exciting part, the rover itself inside the heat shield and back shell with its rocket-powered jetpack called the Sky Crane descent stage. All that is a payload as far as the cruise stage is concerned. And that takes about 6.5 months, as I mentioned, to get from Earth to Mars. So essentially like a space plumber, health and safety of that entire propulsion system, all the engines, the tanks, the valves, thrusters, heaters, pressure and temperature transducers. So it's maneuver design, because we do little trajectory correction maneuvers or TCMs on the way to Mars to correct the path. Health and safety of the vehicle there, looking at turn performance during spin rate changes, turns, just trying to keep the system healthy and work with the attitude control and navigation teams to refine the trajectory to nail the Mars landing February 18th, 2021.
And how fast is it that the spacecraft is going as it approaches Mars?
Yeah, relative to Mars, as we get close, we're about 13,000 miles an hour, or 21,000 kilometers per hour. And that's a big problem because we have to go from that to 0 miles per hour in about 7 minutes. So hence the infamous 7 minutes of terror.
Yeah.
Using all kinds of things like heat shields and supersonic parachutes, propulsive descent, and then the sky crane maneuver to finally have we end up laying the rover down on the surface of Mars, if everything works, more gently than you lay a baby in a crib, just a couple of feet per second. But a lot has to happen for that to be safe and successful.
And is one of the reasons that you are pretty much landing the same way Curiosity did because the Curiosity landing was so successful?
It is, although I like to remind people, we've done this one time. We're 1 for 1. That does not exactly make a huge track record. So we hope for the best and hope Mars doesn't throw us a bad day. But yeah, it worked well for Curiosity, and we like this landing system. We're excited and crossing our fingers, hope it works well for Perseverance as it did too.
And how many thrusters, if that's the right word, are actually used in the final descent to slow it down just before it's going to deposit Perseverance on the surface?
Right, so we call those the MLEs, Mars Landing Engines, and there's 8 total, and it's 2 next to each other on 4 different sides of a square, basically. And those are, I forgot the thrust level, it's pretty high thrust. So this is we like to say it's on the scale of 2/3 of the size of the Apollo lunar lander. And this was a JPL propulsion in-house build for both Curiosity and Perseverance descent stages. So we're very proud of that at JPL propulsion.
That's awesome. And you said that it's 2/3 the power of the landing engine that
2/3 the size. So it's roughly the same scale as the human Apollo landed mission. So that, by our standards versus past missions, that's a very big propulsion build at JPL.
What is it that makes the Perseverance mission significant? Like, why we've had so many missions: Spirit, Opportunity, Curiosity, Phoenix. There's one up there now, right? Begins with I.
Insight.
Yeah. Insight's up there. So what's special? Why are we doing another mission to Mars?
Great question, David. Very fair question, too. So this will pick up where prior Mars missions have left off. We have new capabilities on this rover versus Curiosity. One of the biggest ones is the ability to cache, C-A-C-H-E, Mars samples in hermetically sealed test tubes, dozens of them. And that is the first step in NASA's long-awaited and dreamt of Mars sample return mission. So the idea is, let's at least get the samples, seal them, and we're landing in a place called Jezero Crater. It's incredibly exciting. Almost guaranteed it used to be a warm, wet place with liquid water, an ancient river delta. So this is an excellent place to, if life ever started on Mars, this is a prime place to look. So one of the big parts of this mission is the first of a few steps in a Mars sample return campaign. We also have an instrument called MOXIE, which can turn the carbon dioxide atmosphere into oxygen. So Matt Damon and others can breathe there in the 2030s. We're making only about 1 gram per hour, and we're not storing the oxygen. It's a technology demonstration experiment, but that's exciting for many future missions, both for robotic Mars missions and human Mars missions. We also have 2 Mars microphones on board. So that's a way to hear the sounds of Mars, the natural sounds and the induced sounds from operating the rover. A way to bring our visually impaired taxpayers and students along this amazing journey of planetary science as well.
Great.
And just really cool. Now, we've sent Mars microphones twice before, and both missions failed. So what don't the Martians want us to hear? That's what I'm and then finally, perhaps most popular with the public, we have a helicopter called the Ingenuity that rides under the belly of the rover. We'll drop it down. It's also a technology demonstration experiment, but this will be a first true Wright brothers moment, powered flight, aerodynamic flight on another world. So we're incredibly excited for all that. Not to mention this improved science instruments, better capabilities, radar for looking beneath the Martian soil, the chemical and geological sensors that are unsurpassed in the history of Mars exploration. So
Wow.
an incredible surface mission awaits us. We just got to get there and stick to land.
Yeah, and what was the name of that helicopter?
Ingenuity.
Oh yeah,
And both Perseverance and Ingenuity were named by students, K through 12 students in the US in essay contests. So that's very exciting. And they got to watch the launch and participate in the mission, the students that named those rovers. And when we picked the name Perseverance, we had no idea how apt that would be for the year 2020. Because
Oh
it's
my
tough
God.
enough to do these missions when things are going well. When
Right.
you throw a global pandemic on it and trying to work and fly, operate these vehicles from home, it's a super challenge. I think we're just we feel very lucky to get to continue to do this work, but it's never been more difficult because of the challenges of COVID-19.
Having a helicopter, obviously the rotor blades spin, and if I remember correctly, the atmosphere on Mars is like 1% density of the atmosphere on Earth. So there's not like a lot of air, Martian air, to grab. What special features are on this helicopter so that it can fly in such a low density atmosphere?
Fantastic question. That's exactly right. 1% of the surface pressure. So it's like flying a helicopter at 100,000 feet on Earth, which is not
Yeah.
really done. So we know the Mars conditions pretty well from prior landers and rovers. So that our aerodynamicists then could be turned loose with those conditions to see how do you fly in a 3/8 gravity environment with cold CO2 at 1% of the pressure level and a very thin atmosphere. And they basically found, well, it has to be lightweight, counter-rotating blades so it doesn't spin up, long, thin, lightweight rotors that go very fast. And we did the aerodynamic design. That's nice to think it'll probably work. We actually tested it on Earth. We simulated a Mars offloading to get the gravity right, and then in a cold vacuum chamber with carbon dioxide, and it flew. But the real proof in the pudding then is our flights next February, March 2019. Sorry, 2021. When we're on the surface of the planet. But we hope for the best. It's a technology demo, which are always risky, high risk, high reward, and we're very excited to do this first powered flight on the Red Planet.
That's really exciting. So I mean, that I think it makes this mission exciting, all those new features, so that people don't have the attitude of, oh, ho-hum, just another mission to Mars. It has a lot of new features that I think are going to keep some of us on the edge of our seats. How is it going to work?
That's great. I totally agree. And even then, I'm surprised too. And as much as I love this, we've landed on Mars before, and I'm just shocked every time we land at the public outpouring of support and love. And especially during tough times, it's just great to turn on the news some nights, and sometimes the only bit of good news you'll see in a whole half-hour newscast is some news from NASA or JPL. So that really fills me with a lot of pride and joy, just to know to brighten people's lives for 10 seconds today.
We kind of alluded to this question, but like, where is or how far along is Perseverance right now? Because it blasted off right at the end of July, so we aren't even at the end of September yet. So whereabouts is it, and is it going, like you said, as we approach Mars, it's going to be going about 13,000 miles an hour. In between, along the way, is it going faster?
Yes, it is. And of course, it depends on what you define your speed with respect to.
Yeah.
All of these standard trips from Earth to Mars are on home and transfer ellipses, which is an ellipse that's tangent to Earth's orbit on the inside and Mars orbit on the outside, a half of an ellipse. That's a minimum energy path to get to Mars every 2 years and 2 months. It's also the time between Mars oppositions, as you well know. This minimum energy path means we can get the maximum science mass or payload from Earth to Mars. Because of the way the ellipses line up versus the orbits, we don't depart from the Earth very fast for a while. Earth continues on its orbit, and so we're kind of still close to 1 AU, but then it starts accelerating rapidly later. Now, with respect to the sun, since we're higher potential energy at Mars than Earth, we're actually slowing down ever since launch. Then, with respect to the sun, we're slowing down until very late on approach. Then we enter Mars gravity well, and Mars's gravity, even at 3/8 of Earth's, accelerates us, and that gets us to that 13,000 miles an hour. We are here, about a quarter of the way or more from our journey from Earth to Mars. And it's, I forgot to look up the exact distance we're traveling for Curiosity. It was 352 million miles. So if you end up working out the math, you actually do more than 1 million miles a day along the path there. So that's 2 round trips to the moon and back.
Yeah. And how often do you have to, like you mentioned earlier, these little jets to kind of tweak the path? How often do you have to do these little tweaks to get the path correct?
Yeah, it's actually not too often. It's I watch a lot of golf. I'm horrible at it, but this is in the Curiosity's case, it's probably very similar for Perseverance. I say it's a par 6, 352 million mile course or hole. And we almost always get an eagle 2 under par because we'll cancel trajectory correction maneuver number 5 and number 6 because we allow 6 burns along the way. The first burn, TCM1, is always right after launch to remove the launch bias. And we purposely build a little bias in because we don't want some of the Atlas V upper stage hardware crashing into Mars because of planetary protection reasons. So we actually bias to the side a little, and that builds in a fixed non-zero value for trajectory correction maneuver number 1. We've accomplished that already on Perseverance. It went extremely well. And then TCM2, 3, 4, 5, and 6 are peppered throughout the trajectory afterwards. With 4, 5, and 6 are all within about the last week and a half before landing.
You described it a little. You mentioned a couple times this sky crane maneuver. So when we do get to Mars, what are just a couple of things? As you said, we're going 13,000 miles an hour. How do we slow down to deposit Perseverance on the surface more gently than laying a baby in a cradle?
Yes. Well, that's where it gets very complicated, and all these steps have to occur in just a few minutes there. Shortly before we hit the atmosphere, we release the cruise stage, and then it goes to unceremoniously burn up in the atmosphere. The part I've worked on so many years that it ends up as incendiary material in Mars atmosphere. The heat shield at that point is pointing forward. We encounter the Mars atmosphere. It gets very hot, surface of the heat shield. We have reaction control thrusters that actually fire out the back to help control it, and we release some weights to give it actually a lifting body characteristic. So it does bank rolls as it comes in, just like the shuttle used to shed speed. So it's not a completely passive aerodynamic entry. And this allows us to really shrink down our landing site uncertainty. We eventually, once the heat shield has done its work, we pop it off. We pop a supersonic parachute about Mach 1.7 or so. And we come down on the parachute, but even on a parachute in Mars' thin atmosphere, that only slows us about to 200 miles an hour. So on Earth, we jump out of airplanes, and even if we're nose diving with no parachute, we go about 180. That's terminal velocity. So the Mars atmosphere doesn't help us enough there. So we drop out of the back shell. We're using radar to figure out where the ground is. We light up those rockets. And at this point, it's just the descent stage as a backpack on top of the rover coming down. The rockets slow the descent until we're about 20 feet or 20 meters or 66 feet off the ground. And at that point, we hover, kill our vertical velocity, and lower the rover on cables down to the surface. And then once the jetpack senses the offload of the mass of the rover touching down, the cables are severed, and the descent stage flies away and crashes, not to be used or needed again, and the rover's ready to go on the surface if everything works.
Well, it's really amazing, and you know, and I'd encourage people to look up the 7 Minutes of Terror. It's a great video clip of how that all happens. It's really amazing.
And it was such a thrill to be in the room when that happened, August 5th, 2012, for Curiosity, and not sure where we'll be in February 2021, you know, regarding COVID-19. If we'll be trying to land this from home, that'd be a real challenge. But hopefully we're back in the office then, and able to share an amazing moment with all the fine citizen scientists of the world.
Back at Mission Control. Well, that's neat. And the date was February 18th. Is that right?
Correct. It's around 12:30 Pacific Standard Time, PM. So on the East Coast, 3:30 PM. It's a Thursday, right in the middle of the work or school day. So hopefully there'll be millions of school kids watching, either, you know, from home or in their classroom safely.
Yes. I know my class will be watching for sure. And
Fantastic.
and so this month, as everybody goes out and enjoys the beautiful views of Mars, a little bit dimmed because, as you already mentioned, about the wildfires are already here on the East Coast, dimming things up. But anyway, when you go and look,
Yep, sorry about
that. Yeah, thank you. You know, binoculars, a small telescope, look at Mars and realize Curiosity is there, alive and well and working, doing science, and Perseverance is on its way. Mars is a very active place.
Absolutely right. And we have some orbiters that are still orbiting the planet dutifully for many years and will serve as relay satellites for our landing and then for the surface mission.
Yeah,
and we
Mars
also have
Reconnaissance Orbiter.
I'm sorry?
The Mars Reconnaissance Orbiter, is it?
Correct. Yeah, with 1 foot resolution pixels when it looks down at Mars at its best resolution, which is just amazing. This opportunity also was marked. The Chinese are sending an orbiter, a lander, and a rover to Mars, and they're on the way as well. And I've heard they've done their first trajectory correction maneuver, and everything went well. And the UAE, United Arab Emirates, are sending their first interplanetary mission, and that's going to be a Mars orbiter. So they all launched before Perseverance did. We all launched within about a week or two of each other. But so far, I've heard everything is doing well on the way to Mars. We look forward to an international arrival there, and really fun planetary explorations for everyone. It's a beautiful way to bring the people on this planet together.
So Mars is the place to be. That seems to be the case.
Every 26 months, that's for sure. And then NASA's had a great record of being able to launch something almost every Mars opportunity, either an orbiter, a lander, or a rover.
Hey, Todd, thanks so much for taking time out of your busy schedule. I know you have meetings that you still have to get to today. Thanks for taking your time to tell us about Perseverance and what you do and inspiring us about this mission to Mars.
Absolutely, my pleasure, David, and keep up your great work. I'm so glad that I was able to give a Mars talk at Boston University a few years ago, and that's where we met. So I was delighted to make your acquaintance, and may you have clear skies. Sorry about the smoke again, and go Perseverance.
All right. Thanks again, Todd. Appreciate it.
Thank you.
I hope you enjoyed that interview with Todd. Now I want to tell you how to find Mars in the night sky. October 13th is the opposition of Mars, which means it's exactly opposite the sun. When the sun sets, Mars will rise. However, a week before that, on October 6th, is when Mars will be at its closest approach with Earth. So therefore, it will look the largest it's going to look in a telescope, 23 seconds of arc, which is quite large. And it is blazing in the night sky at a negative 2.5 magnitude. You cannot miss it in the eastern sky. It's the brightest object, unless the moon happens to be out in the area. And you're going to also find that it is very, very red. So let's just take a peek here. We're looking October 13th towards the east, just south of east. This is a couple hours after sunset, and you can see Mars is decently above the horizon, very easy to find. I have these constellation lines up, and those happen to be of the constellation of Pisces, the fish. So that is where Mars is located. The best time to see Mars, however, will be around midnight, when it's as high as it's going to get above the horizon, out of as much atmosphere as possible. Around midnight would be the best time to look at it through a telescope. And Mars is not going to look this good again until the year 2035. So another 15 years to wait. So don't miss Mars this month in October. A week or so either side of October 13th will be just fine. And again, the later in the evening, around midnight, is your best time for looking for it. And remember, as you look at Mars, Curiosity is up there doing stuff. Perseverance is on its way, and it's going to be landing February 2021. Hope you enjoyed the show. I'm Dave McDonald.